Hello, here's section 5.3. We're going to start with some basic functions and what their graphs look like. First, we're just going to go over a quick review of what I think is basic algebra, how cube roots work, and then we'll look at how that affects the graphs of them, which is more of an intermediate algebra topic. So first, here's the definition of a cube root. We say that b is the cube root of a if b cubed equals a. And this is the cube root symbol. It looks like a regular square root symbol, but the 3 means we're talking about a cube root. So the result of the cube root should be a number you can cube and get a. All right, so let's just do a quick example of some stuff. So here you have the square root of a negative number, and we remember that there is no real number you can square and get -9, because -3 squared is 9, and so is +3 squared. None of them give you -9, so this has you could say it's undefined, or you could just say that the answer is an imaginary number, 3i. Now let's look at the cube root of 8. So whatever this result is, if we say this is equal to b, then what that means is that that number b cubed needs to equal 8. And if you think about it for a second, what can you multiply by itself 3 times? You'll get 2 cubed equals 8. So that means that the cube root of 8 is 2. Okay. But if you think about -8, let's see, is the answer -2? That would be a good guess. Let's see what happens. If you do -2 to the power 3, that would mean -2 times -2 times -2 3 times. And 2 of them give you a positive result. That -2 times -2 gives you 4 here. So those 2 combine into 4. There's still this other -2, and then that gives you -8, because you now have a negative times a positive, and so the result is -2. Okay, so that is that. Just wanted to do a quick review of that. Let's go on to another example. I would like you guys to try this one on your own. And the important thing is that you try it and get an answer. You don't necessarily need to get the right answer, but just correct your wrong answer if it's wrong, and you can skip the explanations in a minute if it is right. So let's pause it. Right, here are these answers, -6 and 7. So the first one, the cube root of -8, that whole thing becomes -2, because -2 to the power 3 cubed is -8, and then 3 times -2 is -6. With this one, you need to first find a number you can cube to get -125. That number is -5. So that whole thing turns into -5 there. But then there's still the negative symbol here, so it's 2 minus -5, which is also known as 2 plus 5, and you get 7. All right. Here's another one, a little extra practice, same deal. Here are the answers, -7 and 9/2. Of course, you could also write that as 4.5 if you prefer. Those are exactly the same number. So, yeah, I just want to, if you got those, great. You can stop this video. I just want to go over a couple mistakes you might have made and talk about how you can correct those. Now, the most common mistake here with A is to take the 5 minus 3 and do that first, and turn that into 2, times the cube root of 64, which would then become 2 times 4, which is 8, but this is not correct. So the problem there is that you're not doing the order of operations. And the order of operations say that you need to multiply before addition and subtraction. And that means you need to multiply that 3 times that 4 first. That multiplication is supposed to happen before the subtraction. And that's how to be careful of that. And a common mistake with B is to do the 6 divided by 2 first and turn that into like 3 minus negative 3. What that would look like is when you reduce this 6 over 2 to become 3 over 1, is you'll get 3 minus negative 3, which is just going to become positive 6, which is not correct. So the problem here is that when you have a fraction bar, that operation should always be done before you actually divide. And the only way you should be able to actually divide it is if you have the top written in completely factored form. So an example of when you can cancel that is if you have something like, let's say, something different like a minus 4 over 2. You can factor a 2 out of the top and write that top as 2 times 4 minus 2 divided by 2, and then reduce the 2's out, and the 2 divided by 2 is just that, and you'll get 4 minus 2 is 2, and that is okay. Because, yeah, if it's written as multiplication like this, the numerator is written as 2 times another thing, and that's all multiplication, then you can reduce a factor. But not if it's only a factor of one term, because you need to be dividing the negative 3 here by 2, but you're not. You're just kind of leaving that alone, and the negative 3 is not being affected by the 2, and that's not the way it's supposed to work. All right, hope that explanation clears that up if you're making that kind of mistake. Let's go on to absolute value in the next one.